All right, so we're going to begin the second part of this video. I meant to have already posted it, but just didn't get around to getting the video made on Friday, so I've had to come back up and do it. Hopefully this will be available over the next couple of days, so if you want to watch it as you study for this, here it is. It's available. So I'm going to knock these out. Again, remember from 16 on, actually start at 11, those are all able to be used with the calculator. Sometimes calculators will help, sometimes they won't necessarily help, but they are available to you. So let's pick up right here on number 16. Again, if you notice the question, it gives me all this. It's a difference of squares, see, x squared minus y squared, and it factors that to x plus y times x minus y. I mean, they're giving you that for a reason, okay? So it says select the choice from each box that correctly completes the sentence. To determine the value of 52 times 48 using the given equation that's up here, let x equal blank and y equal blank. Well, again, think about this, guys. If I have two parentheses here, one of which is x plus y, and the other is x minus y, think of what value I would have to add and subtract to x consistently in both of these to give me 52, 48. So what you do is you divide that gap. You see, how big of a gap is that between 52 and 48? Well, that's 4. If you cut that in half, that's 2. You're talking about an x value that's 50, right? Because if I add a number to 50 to get me 52, that's the same number I would have to subtract to get me down to 48. And what is that value? Well, it's 2. See, 50 plus 2 equals 52. 50 minus 2 equals 48. So my x value would have to be 50, and my y value would have to be 40, or it would have to be 2. So again, I know that was kind of a confusing problem. You've probably never seen one like that before. But just as you think about it logically, if you really look at it, it's actually a pretty simple problem. Okay, number 17. It says a researcher wants to determine if the behavior of children is affected by playing video games that have violent content. He asked the parents of 100 children in a daycare center how often each child plays video games and whether the video games they play have violent content. The children are then allowed to play in that controlled environment, not play the video games, but just play with each other in a controlled environment, such as the daycare center's playground. Any violent behaviors are then noted. And it says, what type of study is a researcher conducting? Again, we know that when we're talking about these different types of studies, we know that a census is if you're trying to reach the entire population, has nothing to do with a study. A sample survey is what kind of group of people are you trying to reach in that survey. That's not the same thing. Experiment and observational is the two that we've talked about. And here's the deal. Experiment is when you try to control whatever that is that you're testing. Observational study, you don't control it. You just know that that's happening, and then you just kind of step back and watch and see how it's affecting or what it's doing. So here's the key with this problem. You're testing to see kids who play video games that have violent content. So if you think about that, asking a kid or making a kid play a video game that has violent content would probably be unethical, right? I mean, you're not going to ask a kid if they, to sit down and then you're basically going to force them, if you will, to play that violent video game. I mean, no one could do that. And that is why, because you can't control that, you're not going to conduct an experiment in this situation because it would be unethical. This has to be an observational study. Okay, parents will tell you whether or not they did or did not play. And then you can watch and see if those specific kids were violent in that controlled environment. But anyhow, definitely not an experiment because of what it is that you're testing. All right, let's move along. Number 18. The function f of x is given by the equation f of x equals 3 times x plus 2. The values of the quadratic function h of x, so these are two different functions, are shown in the table below. So which statement about the y-intercept? Okay, now remember, y-intercept is where your graph is crossing the y-axis. Where it's crossing the y-axis. So I've jotted this one down right here because I want you to consider that point right there. How would I name that point? Well, we always start with x, right? So I would go nowhere left. I would go nowhere right. I would go 0 on x. But then my y value would go down. So negative some number, right? Well, I mentioned that because right here, that ordered pair describes the y-intercept for this function f of, or h of x. It's at 0, -6. 0, -6. Okay? So here's the deal. I need to find the y-intercept of f of x. That way I can actually compare them to each other. So I'm going to go to my graphing calculator, and I'm going to type in 3 times x squared plus 2. And I'm going to graph it, and you're welcome to look at the graph, and you can look and see that's at 1, 2, 3, 4, 5, 6. Or you can look at the table, once again, at where x is 0, and sure enough, there's my y-intercept at 6. So what we have here is we have a y-intercept on f of x that's at 0, +6. We have a y-intercept with h of x that's at 0, -6. Well, how far are those from each other? Well, from 6 to -6 is 12 whole units. So m, it is 12 units above the y-intercept of h of x. Okay? That's what we know. So use your graph and make sure you understand what you're comparing. We're talking about the x-intercept. We would be looking for where y equals 0, but we're looking for y-intercept, so where x equals 0. Okay? Moving on, number 19. A survey of 410 students. A survey asked 410 students whether they would eat food served in the school cafeteria. The results are recorded in the table shown. So there you have, you got all your different grades in high school, and you got yes or no. So it says, what is the probability that a student will not eat food served in the school cafeteria, given that we talked about this when we were doing probability, given that is going to narrow what group you can actually look at. So this says given that what? The student is in the 10th grade. We're only looking at this group. If we're only looking at this group, my bottom number will be 63 plus 47. So 63 plus 47 is 110. So my bottom number is 110. Now remember, we're talking about only this group. So out of that group, what's the probability that a student will not eat food served in the school cafeteria? No was 47. So it's 47 out of 110. I know that's my fraction. But what does the question ask? Enter your answer rounded to the nearest hundredth in the space provided. So I'm going to go back to my home screen and type in 47 divided by 110. And it says to round to the nearest hundredth. That's 2 decimal places. So that 7 is going to round that up to a 3. So 0.43 is my answer. 0.43. Sorry, not a great 4. More like a 9. Okay, and that's it. That's all for number 19. Let's keep on rolling. Number 20. A rock is dropped from a hot air balloon at a height of 100 meters. I'm going to just try to picture this. Here's the ground. There's a hot air balloon way up here. It's going to be a great picture. There's my hot air balloon. And it's 100 meters up. Okay? 100 meters up. And it says that this rock is dropped. And it's modeled by this equation. -4.9 t squared plus 100, where t is time in seconds. Okay, so we know that it's this high. So we're talking about feet up in the air. I think it's feet. Let me see. 100 meters. I'm sorry. So it's 100 meters up. And we know that time is on the bottom, and it's in what we see. It said it's modeled in seconds. Time is in seconds. Okay? So it says, what is the average rate of change in meters per second of the height of the object between 2 and 4 seconds. All right, so I ended up doing probably a little bit more work than I needed. I just need to find, as this thing is falling, what's the average rate of change from 2 seconds to 4 seconds, okay? Now, again, I did probably too much work. I didn't really need the drawing. But I'm going to go ahead now and explain how I'm going to find average rate of change. For average rate of change, it's slope. We're trying to find this slope right here, this spot from 2 seconds to 4 seconds. And the way I'm going to do that is I am going to go to my calculator and I'm going to find ordered pairs. I'm going to find ordered pairs for negative 4.9. Instead of t, I'm going to use x squared plus 100. And I'm not going to go look at the graph. The graph is not going to help me at all. What I really care about is the table. And I'm going to look at these two ordered pairs right here. At 2 seconds, it was at 80.4. And at 4 seconds, it was at 21.6. You see, that's what I need to do average rate of change. Because we said to do average rate of change, you're doing slope, right? You're doing change in y over change in x. So if this is my first x and y, and this is my second x and y, I'm going to follow the old slope formula where I go y2 minus y1 over x2 minus x1. So 21.6 minus 80.4 is going to be negative 58.8. And of course, 4 minus 2 is 2. If you type that in a calculator, you're going to get negative 29.4. My average rate of change from 2 seconds to 4 seconds is negative 29.4 C. All right? So that drawing lesson, that was a free one. You didn't even need it, but I like to visualize things sometimes in case a question goes that direction. All right, let's move along to number 21. 21 was the second day that I gave you Friday. So pretty easy question here. I doubt many of you guys missed this one. It says each graph shows the velocity of an automobile as a function of time. So we're doing velocity over time. Okay, velocity is how it's moving, and then like if it's going faster, slower, and then of course time is pretty self-explanatory. It says which graphs plural, indicate that the automobile is not accelerating. So think about what accelerating means. Accelerating means it is going up in the first 40 seconds. So I'm just going to simply look at the graph in the first 40 seconds. Is that one going up? Yes, then that one is accelerating. I'm picking the ones that are not accelerating. Look at this first 40 seconds. Is it going up? Yes, it's accelerating. I'm picking the ones that are not accelerating. So A and D are out. Okay, let's look at the rest of them. Look at B. Is this one accelerating over the first 40 seconds? No, it's decelerating. It's not accelerating. So B is the correct answer. What about this one? Is it accelerating over the first 40 seconds? Definitely not. It's going down as well. So this one's not accelerating. And then finally, C, well, it's not going up and it's not going down. So remember, is it accelerating? No. So it's not accelerating. So therefore, it is an answer. So here, your answers are B, C, and E. You just need to know terminology and how to look at a graph and figure out what it's saying. Accelerating means it's going up in speed and velocity, so therefore the ones that show that it's not going up have to be the ones that are not accelerating. There's 21. 22. Given the polynomial 2x squared plus x minus 15, determine the values of x where the graph of the polynomial crosses the x-axis. Select one, blah, blah, blah. Listen, don't overcomplicate this. Could I factor this? Sure. But it's telling you the easiest way, and plus, even if it doesn't say this, even if it doesn't say find where the graph of the polynomial crosses the x-axis, even if it doesn't say that. Please remember, you have a calculator. When they give you a function and they give you all these solutions, you can find those solutions. You can go to your calculator, you can go to y equals, you can type that function in, 2x squared plus x minus 15. And if I graph that, all I have to do is look and see where it's crossing the x-axis. This one looks like it's crossing at -3. So I'm going to jot that down, -3. And this one looks like it's crossing somewhere between 2 and 3. Somewhere between 2 and 3. So let's go and look at our answers. You have them in front of you. So I look at this group. Do you see any -3s there? No. Do you see any between 2 and 3s? Well, sure, right there, 2.5. I mean, I could have looked specifically at the graph and found that it was 2.5, but I didn't even need to because that's the only choice that matches. Now look at the bottom, and the other solution is -3. There it is. So 2.5 and -3. Use your graphing calculator. Graph them and look and see where they cross the x-axis. Okay, another one right here. There's a couple ways that you could do this. All right, one, don't forget, if your factor is x plus 2, your solution is -2. So real quickly, I could go back to my calculator here, and I could at least narrow this down. Look, x to the third minus x squared minus x minus 2. If I were to graph this, does it cross the x-axis at -2? No, of course it doesn't. So let me go back to here. Is x plus 2 a factor? No chance. It never crossed at -2. So I can get rid of m and I can get rid of s. Okay, that was easy. Okay, another way that you can narrow it down from here is I can remember what makes it a factor. What makes it a solution? The remainder being a 0. It cannot be, no, the remainder is 0. If the remainder was 0, it's yes. So the answer has to be R. I mean, there's no way around this. And all I had to do was just look at my solutions. Now, here's the way I did it algebraically. I put -2 in the box, and I used synthetic division, synthetic substitution. I started right here with this x cubed coefficient of 1. And then I went down to x squared, -1. And then I went down to x, another -1. And then I went all the way down to my constant, -2. And I use synthetic division. Remember how we bring that 1 down and we start multiply combining? The remainder is that final value. I guarantee it's going to be -12. Watch. -2 times 1, -2. -1 minus 2, -3. -2 times -3, +6. +6 minus 1, -6. +6 plus 1, or 6 minus 1, that's 5. I don't know what, I just went brain damage for a minute. That's +5, 6 minus 1. And then 5 times -2 is -10. And what's -2 minus 10? Well, there you go. It's -12, just like I said it would be. The remainder is -12. It is not a function, or it's not a factor, because the remainder was not 0. So it's no, and the remainder is -12. Easy problem, should be. Okay, number 24. The graph shows the exponential growth of a number of organisms in a petri dish over a 12-hour period. And it gives you the table, gives you the function. To the nearest whole organism, how many organisms are expected to be in the petri dish at 24 hours? So look, here's a situation where you don't have a multiple choice, so you can't just kind of guesstimate where you think it's going to end up, okay? So I want to remind you of something that we can do that actually makes this really simple. Remember, it uses the word exponential growth. You see, you know that this is asking you to deal with an exponential function. So you probably forgot, but do you remember when we took these values and we went into stat edit and we entered all of our data? we have 0, 2, 4, 6, 8, 10, 12, and then, whoops, I did 15. Let me fix that real quick. 12. And then over here with 0, we did 25. Then we did 36, 52, 68, 88, 104, and 151. So I'm going to graph, or not graph this, I'm going to run, if you guys recall, I'm going to run what we call a exponential. We go to stat, calculate. We're going to run what we call an exponential regression equation. What it'll do is it'll actually write the equation for me. So you go to stat, calculate, and then you go down here and run an expreg, exponential regression, and it will write your equation for you. Remember, it gives it to you. A times B to the X. A is 27. Let me write this down. It's 27 point, we'll round to 2 decimals, 0.03 times B to the X. Well, B is 1.15 raised to the X. So my calculator wrote the equation for me. Now, to the nearest whole organism, how many organisms are expected to be in the Petri dish at 24 hours? So all we're going to do is we're going to type in 27.03 times 1.15 raised to the 24th power. So here we go. 27.03 times 1.15 raised to the 24th power. And it tells me 770, looks like it would round up to 4. 774 is my answer. Okay, now you might get a different answer if you rounded differently. But anyways, I think you're safe at 2 decimals. Okay, 2 decimals. All right, so pretty easy problem there if you know how to do that. Number 25. Calvin purchases a piece of heavy machinery, $32,300. The value of the machine depreciates. Depreciates is on your formula sheet. On your formula sheet, it says A equals P times 1 minus R to the T power. So here we go. P. P is your principal amount, $32,300. And then it's 1 minus your rate, that's 0.083. Remember, move it 2 decimals to the left, and that's raised to the T power. So if I simplify that, that's 32,300 times 0.917. Now, listen, here's where you have to say, wait, none of these look like that. Well, you know B doesn't look like that, and you know D doesn't look like that. Because they have the wrong, they added instead of subtract. Depreciate subtracts. So last thing, how do I know which one of these it is? Well, if you guys recall, when we took monthly depreciation rate, what we did is we rose that power inside, or that value inside to the 1/12 to break it down to monthly. But you have to make up, you can't change the whole equation. To make up for that, you would raise it to the 12T power. So what you did on the inside, you had to kind of make up for on the outside. Well, the one that does that is C. C is my answer. Okay? It's not this one because it didn't do it to both. So it's definitely C. All right? So use depreciation. Then you can narrow down A and C. And then, of course, hopefully you guys recall, if it says something about monthly depreciation, you have to do the 1/12 inside, 12T outside. Okay, number 26 is just such an easy problem. I mean, look at this, guys. You know how to deal with proportions, right? To solve a proportion, you cross multiply. Look, did they cross multiply to get to step 1? I mean, what happened? I mean, it looks like all they did was they let 5/5 reduce down to 1/1. I can't do that. You know you can't let part of the numerator or denominator simplify with the numerator. You can't do that. So Jamie is definitely wrong. Okay, let's check out Taylor here. 1 times 2x plus 5 does give me 2x plus 5. And 5 times x plus 3 does give me 5x plus 15. It looks like they got their numbers together. They subtracted 15 to bring it over here to this 5. And it looks like they subtracted 2x to move it over here with that 5x. So far that looks good. Then they simplified this. 5 minus 10 is negative 10. Yep. 5x minus 2x is 3x. Yep. Then they divided by 3. Yep. This is perfect. They did all the work right. So Taylor is right. Taylor is right. So it can't be Jamie is right. This one says Taylor is right. This is Jamie is wrong. Okay, hang on. Because step 2 to step 3 should know. He missed it. Jamie missed it right from the get-go. Taylor is wrong. Nope, Taylor was right. So it has to be P, because 1 times 2x plus 5 is equal to 5 times x plus 3. Cross multiplication. Easy peasy. All right? Moving on. Number 27. The graph is shown below. Okay, remember this. 2 graphs. System of equations. So our focus are, where do they cross? They cross right there at 0, 1. And they cross right there at 2, 5. 2, 5. So, what's the question? What are the x values for the solutions to the system? Enter 1 in each response box. Okay, what are the x values of those solutions? 0 and 2. That's easy, man. Y'all will definitely not miss that on the test. 28. Again, it's the very same problem we had earlier, except they gave us the table. They want to know what is the average rate of change from t equals 1.5, so that's here, to t equals 2.0, that's here. So again, the same as we did earlier, I'm going to label these. Let's call this my first x and y. Let's call this my second x and y. So we're going to do y2, 9.6, minus y1, 10.7, over x2, 2.0, minus x1, 1.5. So grab your calculator, and you're going to type that in. 9.6 minus 10.7 is negative 1.1. And then 2 minus 1.5 is positive 0.5. If I divide that, that's going to give me a negative 2.2. So how does it say enter your answer? That's it. So we're just going to enter negative 2.2. All right. Now, again, I told you guys that I wanted you to ignore all the other parts. So we're not going to look together at B, C, D, and E. If you want to ask about those later, you can. But that we took that off. Okay, number 29. 29. The graph of the function is a parabola. Plot the x-intercepts, y-intercepts, and minimum and maximums. Okay, so let's see. Let's start with the x-intercepts. Let's go to our graphing calculator, and let's type this thing in. 2x squared minus 3x minus 5. And we're going to start with these x-intercepts. Looks to me like negative 1. And it looks like looks like between 2 and 3. So let's look and see. Let's look at our table. Is negative 1 one of them? Wrong way. Yeah, negative 1 is one of them. And if you notice right here between 2 and 3, sure enough, it's crossing. So I'm just going to kind of put them between between 2 and 3. So there's my x-intercepts. They don't have to be perfect. Next, it says y-intercept. Okay, let's look back at our graph, and let's see if we can see that y-intercept. It's down here. Look, negative 1, 2, 3, 4, 5, somewhere around negative 5. Let's see. We can look at our table, and sure enough, 0, negative 5. 0, negative 5. Okay, let's see what else it asks about. It asks about your maximum or minimum to the nearest half unit, whichever one exists on the coordinate plane. Okay, so look, if I go back to my calculator or back to my graph, I can find this. In this case, this is called a minimum. So I go to second trace. Don't forget about second trace. And I'm going to do a number 3, a minimum. So I go just to the left of it, push enter, Then I'm going to go to the right of it, push enter. I'm going to push enter one more time, and that looks like 0.75 negative 6.125. So I try to draw the graph as good as I can, and there it is. So it looks like the minimum's here, and it goes up. Oops, no, I want it to curve here. It goes up and out. That's not beautiful. And then this one does the same thing, the opposite direction. So boom, there you have it. Okay? Now, number 30. Number 30 says, select each function that has an inverse that is also a function of all values of x. Okay, so this is an easy one if you understand what you're talking about. You see, for something to be a function, it has to pass the vertical line test. And if you guys recall, we said that if I were to graph an inverse, it basically is a reflection over the line y equals x of our original function. So basically, here's the deal. If I want to figure out if not only this is a function, but also its inverse is a function, this thing has to pass the vertical line test and it has to pass the horizontal line test. Okay, for both to be a function, the original and the inverse, they have to pass the vertical and the horizontal line test. So let's look at m. I'm going to go and type in 2x squared plus 4x minus 3. Does this one pass the vertical line test? If I were to take, and I wish I had something that I could show you, but if I were to take a vertical line and go across it, would I ever touch more than one point at a time? No, it passes the vertical line test. But if I were to take a line and move it up this way, see how it would cross multiple points? So this doesn't cross the horizontal line test. So the inverse would not have a function. So m cannot be it. Okay, look at p, 2x plus 3. 2x plus 3. Does it pass the vertical line test? Oh yeah. Does it pass the horizontal line test? Definitely. P is an answer because it passes both the vertical and horizontal line test. Look at the next one. We got alpha y equals number 1, 3 over 2. And then out in front of that, x plus 3. Oh, I'm sorry, plus 2. Does this one pass the vertical line test? Yep. Does it pass the horizontal line test? Yep, it passes both. So R also is an answer. Let's go to the next one. We've got 2x cubed plus 2. Whoops, I don't want it up there. Plus 2 down here. There we go. Does it pass the vertical line test? Yep. Does it pass the horizontal line test? Yep. That one too is an answer. And the last one, we've got 2x to the fourth. We got plus 3x squared minus x plus 1. Does this one pass the vertical line test? Yes, but it does not pass the horizontal line test, so it cannot be the answer. So when it asks a question, can each function have an inverse that is also a function? Well, for this to be a function, pass the vertical line test. For the inverse to be a function, it has to pass the horizontal line test. So that's why we chose P, R, and S. It passed both the vertical and horizontal line test. Okay? All right, last one. If you don't have a calculator, you're going to solve this. I'm sorry, if you don't have multiple choice, you're going to solve this using this way we solved exponential and logarithmic equations. Let me explain. To solve 4 times 10 to the 3t equals 12, we want to solve this exponential function. We know it's exponential because the variable is in the exponent spot. So what we have to do is we have to isolate the base of that exponent. Okay, so what do I need to get rid of then? 4. Well, since I'm multiplying by 4, I got to divide by 4. So 10 to the 3t power will equal 3. So how do I solve an exponential function now that I have it, or an exponential equation now that I have it isolated? Remember, this is where you rewrite it as a log. Rewrite it as a logarithm. So I'm going to rewrite it with log, because it's not an e. Remember, I would put this value as the base of your log. But if I don't put anything right here, isn't it understood to be log base 10? Now, feel free to put it if you like. But then do you remember what we did from here? We did the loop. Log base 10 of what equals what? Well, log base 10 of 3 equals 3t. So look, if I were to go back to my calculator, there are two ways I could type this in. I could just type in log of 3, or if I wanted to, I could do alpha window number 5, if you forget this. And if I did log base 10 of 3, notice how it's the same thing. So log base 10 of 3 is 0.477, and that equals 3t. So again, how am I going to solve? I'm going to divide by 3. So if I divided that by 3, it's going to round to about 0.159. But what does the question ask? It says, enter your answer. Okay. Earlier we were supposed to round to 2 decimals. Oh, here it is. The nearest hundredth. So we are going to round to 2 decimals. So that is 0.16. And that's it, y'all. That is about all there is to it. We have done quite a bit of review. I feel really confident in what you guys have looked at over the course of the last couple weeks. I think you guys are going to do great if you try your best on the test. Remember, it starts on Wednesday. I mean, we're really close. So do some last minute studying. Remember, in class on Tuesday, we're going to go through the reference sheet a little bit. We're going to look at some calculator stuff, just kind of last minute, just to remind you guys of what you can do on that thing, where it actually helps you out quite a bit. But anyways, study this if you want. If you don't want, study your old reviews. Be ready for your test on Tuesday and Friday of this week. See you soon.